Good afternoon, everyone. My name is Yuk Sharma, and our project title is Animal Image Classification. My teammates are Akash Sharma and Tejasri Kulkarni, and we worked on this project together. Talking about the content, I'm going to be starting with data pre-processing, introduce a little bit about our project, how we did the data extraction, and how we prepared our data for our model to use. Then I'm going to be talking about the model building and training part, and then how we evaluated our model based on two metrics, which is the training and validation loss and training and validation accuracy. And finally, I'll be talking about the prediction analysis. So we aim to develop a neural network that detects and identifies different types of animal species in real time, predict the class of a given animal, enabling us to determine how many input images belong to each class. One potential application of our project is to provide an autonomous way of animal classification in a more efficient way than other traditional methods. So we got our data from Kaggle, which consists of 5,400 animal images and 90 diverse classes of animals. That consists of multi-channel images, which is the RGB. For the data exploration part, we computed mean and standard deviation, which in order to basically find out the overall brightness and contrast of the pixels. Then we plotted histogram of pixel intensities for enhanced pre-processing decisions. Thirdly, we analyzed image size distribution for figuring out the resizing requirements for standardization, and then we examined distribution of classes and their categories in the dataset. Now the data preparation part. So we loaded our dataset with labels and then converted labels to numbers. So our number dataset has had total of 5,400 samples. We further subdivided our number dataset to three parts, which is, first one is training dataset, which has 3,800 samples. Second is validation dataset, which has 1,100 samples. And then there's a testing dataset, which has 450 samples. And each sample measures 224 by 224 pixels. Now, introducing our baseline model. So we loaded a pre-trained model named Efficient NetB3 model, and we did layer freezing and data augmentation. And then after providing the inputs to the model and compiling it, we found out this summary. This summary is basically an architecture of how our model is um what our model incorporates. So for example, the number of layers, name of the layers, and how many parameters is each layer using and all. Now after compiling this model, we we got a pretty decent validation accuracy. As you can see here, that as we increase our epochs, our level of loss decreased significantly, and also our level of accuracy increased significantly. But we wanted to fine tune our model and improve our accuracy. So we did this by using additional layer freezing, adding custom top layers and input layers, adding custom classifier heads, and then compiling it again. Now, the optimization strategy this time was that setting the atom optimizer equal to 0.0005, also setting the loss function equal to categorical cross entropy. This improved our model performance a little bit to 92.5%. But now we wanted to find out where our model is performing unwell, like not performing good. So we use two metrics for this. First one is most confident errors. This basically shows us the comparison of true animal classification versus the predicted classification of our model. And we found out that most of the examples um, in the samples are basically animals who have very closely related characteristics. For example, rat versus a hamster or butterfly versus a moth. Secondly, we use confusion matrix. So as you can see that our model was able to predict the animal classification for most of the parts, but some are the instances where our model was not able to predict the animal classification correctly, like this and then here. So these two metrics gave us a sense of where our model is not performing well and where we need to further optimize our model in order to basically improve our efficiency and accuracy level for our project. Thank you.